reduction reaction. So, the definition of oxidation and reduction is oxidation and reduction are chemical processes that occur together. Oxidation is the process in which a substance gains oxygen, while reduction is the process in which a substance loses oxygen. These two reactions happen simultaneously in a redox process. 4.1.1 is transfer of oxygen. The definition is transfer of oxygen is the process where oxygen is either added to or removed from a substance during a chemical reaction. As you can see the example, Fe2O3 plus 3CO, we can get 2Fe plus 3CO2. In this reaction, both oxidation and reduction occur at the same time. For oxidation, carbon monoxide gains oxygen to form carbon dioxide. For reduction, iron trioxide loses oxygen to form iron. The number of oxygen atoms decreases from 3 to 0, so reduction occurs. Therefore, oxidation and reduction always occur together in the redox reaction.
Transfer of electrons. A redox reaction happens when electrons are transferred from one substance to another. In this process, oxidation occurs when a substance loses electrons, while reduction occurs when a substance gains electrons. A simple way to remember this is by all-Rick. Oxidation is loss of electrons and reduction is gain of electrons. For example, from Na to Na plus E plus electron shows oxidation because sodium loses an electron, while from Cl2 plus 2 electron will be 2Cl minus, shows reduction because chlorine gas gains electrons. Change in oxidation number. Redox based on change in oxidation number. Every atom in a compound has oxidation number. It's like a charge score. Redox can be identified by checking whether this number increases or decreases. As an example, for oxidation, the compound oxidation number will increases, while reduction, the compound oxidation number will decreases. One of the compounds that the oxidation number increases is ferrum. It increases from 2 plus to 3 plus. The oxidation number for ferrum increases, so it is oxidation. And for reduction, it decreases from 0 to 1 minus, from chlorine to chloride.
4.1 Transfer of hydrogen. In this slide, oxidation is defined as the loss of hydrogen atoms from a substance. Conversely, reduction is defined as the gain of hydrogen atoms. In the reaction shown, 2NH3 plus TBr2 equal to N2 plus 6 HBr. Ammonia undergoes oxidation because it loses hydrogen to become diatomic nitrogen. Bromine undergoes reduction because it gains hydrogen to become hydrogen bromide. Each atom in a molecule or ionic compound is assigned an oxidation number or oxidation states. So, what is oxidation number? The number of charge the atom would have in a molecule if electrons were transferred completely. Next, rule to determine oxidation number. The process of assigning an oxidation number to an element follows a set of general rules that ensure electrical neutrality or proper charge accounting. Firstly, the oxidation number for an atom in its elemental form such as Na, O2 or Cl2 is always 0. Secondly, for a simple monoatomic ion, Na plus or Cl minus, the oxidation number is simply equal to the charge of the ion. The final, crucial general rule is that the sum of the oxidation number values for all atoms in a neutral compound must equal 0. Conversely, for a polyatomic ion like SO4 2-, the sum of oxidation number Values for all constituent atoms must equal the overall charge of the ion. Beyond these general principles, there are specific rules for periodic table groups and key elements. Group 1A elements always have an oscillation number of +1 in all compounds, and Group 2A elements always have an oscillation number of +2 in all compounds. The element hydrogen typically has an oscillation number of +1 when combined with nonmetals, but it assumes an oscillation number of -1 when combined with metals and boron. The rules for oxygen are more varied. Its most common oscillation number is -2 in all other compounds. However, in peroxide, like H2O2, its oscillation number is -1, and when combined with metals, nonmetals, except O2, and other halogens lower in the group, the elements in group 7A primarily take an oscillation number of -1.
Now we will move to 4.3, reducing and oxidizing agent. First, I will introduce you about reducing agent. The reducing agent is referred to the species which is being oxidized itself, called electron burning. There are some characteristics of reducing agent, that is, it can cause reduction, it is oxidized, and it loses electron. Then, I will tell you about oxidizing agent. The oxidizing agent is referred to the species which is being reduced, that called electron acceptor. There are some characteristics of oxidizing agent, that is, it can cause oxidation, it reduces, and it gains electron. Now we will learn about the determination of reducing and oxidizing agent. There have one tips that we can follow, which is we need to identify the substance oxidized and reduced. Oxidized substance is equal to reducing agent, while reduced substance is equal to oxidizing agent. So, for the conclusion is oxidation means reducing agent, while reduction means oxidizing agent. For this example, identify the oxidizing and reducing agent for the redox reaction. First, let's look at aluminium Al. It starts as a pure solid with an oxidation number of 0 and increases to +3 in the compound Al to SO4 3. Since the oxidation number increased, aluminium underwent oxidation, which makes Al the reducing agent. Now look at hydrogen H in H2SO4. It starts at +1 and decreases to 0 when it forms hydrogen gas H2. Because the oxidation number decreased or was reduced, the H2SO4 is our oxidizing agent. Now, let's look at its reaction between gold ions and iodide ions. First, notice the gold ion Au power of 3 plus. Its oxidation number changes from +3 to 0. Because its value decreased, now it underwent reflection, which identifies Au the power of 3 plus our oxidizing agent. Next, look at the iodide ion, I to the power of minus. Its oxidation number increases from -1 to 0. Since the number increased, it was oxidized, making I to the power of minus the reducing agent. In this next example, we have a more complex equation involving several compounds. To find the agents, we focus specifically on the atoms that change their oxidation states. Take a look at the chlorine Cl in KCl. It starts at -1 and ends up as 0 in the chlorine gas Cl2. Because the oxidation number increases, KCl acts as the reducing agent. Meanwhile, the manganese Mn in MnO2 drops from plus 4 to plus 2. This decrease in number tells us it was reduced. So, MnO2 is the oxidizing agent for this reaction.
4.4 Balancing redox equation in acidic medium and basic medium. First, we separate the reaction into half reactions and determine the ON for species undergoing redox. Second, balance atom and charge in each half reaction. Parts add the half reactions together, cancelling substance that appear on both sides. And last, check the atoms and charge balance.